This is the 4.1 classifying triangles in the coordinate plane lesson. So with number 1, what you're doing here is you're going to graph the triangles from the vertices that they give you and then decide if it's scalene, isosceles, or equilateral, and acute, right, or obtuse. And if it's equiangular, then all of the side angles would be the same. So let's graph. So A is 1, 6. So 1, 6. B is 1, 2. And C is 4, 2. Take your straight edge and connect the points with a straight line. Now to figure out the lengths, since AB and BC are parallel or horizontal and vertical, we can just count. So AB looks like it's 1, 2, 3, 4 units, and BC is going to be 1, 2, 3 units. AC, we will use the distance formula, or you can use the Pythagorean theorem since this is a right triangle, since AB is vertical and BC is horizontal, and a vertical and horizontal line are perpendicular. So we do know that this is a right angle. Otherwise, if we didn't have that, we would have to use the slope to determine if it was a right angle or not. So anyways, AC, let's set up the distance formula. So I would subtract VX's. It doesn't matter what order you go in for these. I just like to subtract it so that it makes it a positive number, but really it doesn't matter because even if you did get a negative number, you're squaring it. So it will become negative anyways after you square it. So anyways, 4 minus 1 is 3 squared plus, and then 2 minus 6. The 2 minus 6 would be negative 4. I'm just going to write 4 squared because I know it's going to come out positive anyways. So this would be the square root of 9 plus 16, which is the square root of 25, which is 5. And actually, this is something called a Pythagorean triple. This is a 3, 4, 5 right triangle. There are different kinds of Pythagorean triples. Really, it's just any 3 numbers that would be the lengths of the sides of a right triangle that are whole numbers. And any multiple of 3, 4, 5 is also a Pythagorean triple. So like 6, 8, and 10, or 30, 40, and 50 would also be a Pythagorean triple. If you took this squared plus that squared, it would be 50 squared. So as you can see, all 3 sides are different, so it would be scalene and right. Number 2, same thing. So let's graph this triangle. This one is a little bit weird because as you can see from the graph, the x-axis is stretched out a little bit. So it challenges us to think that we can't just decide by looking at the graph whether it's right, acute, or obtuse, because if it is like this, then it will look different, and we really need to find the numbers. So we need to do the distance formula and find the slope to figure out whether the angles are right, acute, or obtuse. So let's graph it. -5, 1. And then B is 3, 5. And C is 2, -3. Going to connect the dots here. Okay, then we're going to find the distance between each of the lines, or each of the vertices. So find AB. That would be 3 minus 5, which is 8 squared, plus 5 minus 1, which is 4 squared. That's 64, 64 and 16, which make 80. So this is the square root of 80. It's okay to leave it like this because we're not really trying to find the answer per se. We're just comparing. If we leave everything under the square root, then we can compare that way. So let's find BC. BC will be 2 minus 3, which is 1 squared, plus negative 3 minus 5, which is 8 squared. And then 1 and 64 make 65. So this is the square root of 65. And then lastly is AC. So this would be 2 minus negative 5, which is 7 squared, plus negative 3 minus 1, which is 4 squared. And that's equal to 49 plus 16, which is also 65. That means that BC and AC have the same length. So BC and AC, so looking at the diagram, it doesn't look like it. But remember that X is stretched out, so we have to go based off of the numbers. Now, to decide if it's right, acute, or obtuse, we will, first of all, just pick the angle that you suspect to be a right angle, because you could do it with all 3 angles, but we'll just do the one, and that would be C. So if it was a right triangle, C would be the right angle because it's opposite of the longest side, AB. So what we're going to do is we're going to find the slope of AC and then draw in what would be the perpendicular line. And if it goes farther than BC, that means it will be acute. If it goes in between, that means the angle here forming would be obtuse because it is greater than the 90. So let's find the slope M of AC. I'm just going to go rise over run. So from A, I'm going down 1, 2, 3, 4. So negative 4 over 1, 2, 3, 4, 5, 6, 7. Okay, so then the perpendicular slope would be positive 7/4. So I'm going to take that from C. I'm going to go up 7 over 4 and draw in the perpendicular line. 1 to AC. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. So that would be the perpendicular line. Therefore, the angle that we have is less than that. So this is an acute angle. So it would be isosceles and acute. Doesn't matter what order you put them in. Acute, isosceles. And you can't just say acute. You have to do this work to prove that it is acute and not a right angle and not obtuse. Okay. With number 3, I believe this is the one. Okay. So I won't spend too much time on this one just to make this video shorter. Go ahead and try it yourself. You should get isosceles and right. Because if you find the slopes of sides AB, the slope of AB ends up being 4, and the slope of BC ends up being negative 1/4. Okay, so I'll let you try that one on your own. And number 4, we'll do this one. So A is 2, 3. B is negative 4, 3. And C is 3, 8. So we're just going to make another 2 tick marks there. I definitely drew this on the wrong point. That would be 3, 8. There we go. So connect your dots. Oops. 4, 3. All right, and then find the distance. So AB, you can just count. It's 6. With AC, that would be 1 squared plus 5 squared, which is the square root of 26. And then BC is 7 squared plus 5 squared, which is 49 plus 25, so the square root of 74. This means that this is scalene. I suspect A to be an obtuse angle. To prove it, I'm going to draw in the perpendicular to AB. Well, AB is horizontal, so that means that the perpendicular would be a vertical line from A. So if I take A, I draw a line going up, move it over a little bit, that would be the perpendicular line, and since this line goes further than that, that would make it obtuse. As long as there's one obtuse angle, then it's an obtuse triangle. You can only have one obtuse angle in a triangle. So this is scalene and obtuse. Okay, in the notes, if you go back a page, then you'll see the exit ticket. You will do number 2 on the exit ticket. And we'll do it, I'll do it right here, because you already did number 1 in the notes. So it was 1, 1, and then 4, 0, and 8, 5. All right, you can find the side lengths. You will find that it's scalene. I'm just going to make the video shorter by just showing you the part where you would do the obtuse angle and draw on the perpendicular line. So I suspect B to be the obtuse angle. So I'm going to find the slope of AB. The slope of AB would be down 1 over 1, 2, 3, so negative 1/3. The perpendicular slope would be positive 3. So from B, I'm going to go up 3 and over 1. So up 3 over 1, draw in that perpendicular line, and I can see then that this perpendicular line is less than angle ABC. Therefore, this angle is greater than 90. It's an obtuse angle. So it's obtuse and scalene. So that's the end of this video. Hopefully that will help you when you take your quiz.